Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a continuation of a lecture video for subject electrical circuits 1, code BEV10303, and in this video we are going to continue our discussion for chapter 3, which is circuit analysis. Okay, so what are the topics that we are going to cover for today? So in this video, basically we are going to see how to perform the nodal analysis when your circuits contain a voltage source. Okay, so for the nodal analysis with voltage source, if you still remember in the video, part 3 video, we had learned on how to apply the nodal analysis, but basically most of the example that we shared contain only current source. Okay, so now we are going to see what will happen when your circuit contain a voltage source. Alright, so basically there are two different cases that we are going to have a look. Okay, so for the first case, for case number 1, we are going to see what will happen when the voltage source connected between reference node and a non-reference node. So what does this mean? By consider the following circuit. Okay, let's say you have this, so you just refer to here. Okay, so here you have a voltage source, and then this voltage source is connected between these two nodes. So this is the first node, this is the second node. Okay, so the first node is considered as a non-reference node, and here we consider as a reference node or ground node. Okay, so when you have this, when your voltage source is connected between the non-reference and the reference node, we can assume the V1 is equal to 10 volt. Okay, so in this case V1 will be equal to 10 volt. So our analysis is somewhat simplified by this knowledge of the voltage at this node. Okay, so let's consider the second case. For case number 2, the voltage source connected between the two non-reference nodes. Okay, so let's consider the same circuit that we have just now. So you refer to here. Okay, so here you have a source of 5 volt, and then the 5 volt is connected between the two non-reference node. Here is the non-reference node, here also a non-reference node. Okay, so this one we can consider as a super node. So normally we create the super node by enclosing the voltage source connected between the two non-reference nodes and any elements that connected in parallel with it. So it means that let's say here you have a voltage source that connected between the two non-reference node, and then you have another element that connected parallel to the supply. Right, so let's say you have another maybe resistor in parallel, right? So you can enclose every single things that connected in parallel to make it super node. Okay, all right, so and then for the once you done assign your super node, then you can apply the KCL to the super node. Okay, so in this case for the super node, the total of current that going into the super node is I1 plus I4 equal to total number of current that going out from the super node is I2 plus I3. Okay, and then after that, once you apply the KCL, you need to apply the Ohm's law to represent your branch current with the nodal voltage. Okay, so for I1, so here is your I1 will be equal to V1 minus V2 divided by 2. Okay, V1 minus V2 divided by 2 plus I4 is given by I4 current will be flow from the higher potential to the lower potential, so that's why V1 minus V3 divided by 4. Okay, V1 minus V3 divided by 4 equal to I2. I2 is here. Okay, V2 minus 0 divided by 8, so here you have V2 over 8 plus I3 is V3 minus 0 divided by 6, so you have V3 over 6. Okay, so this equation we call as a super node equation. Okay, and then we need to apply KVL to the super node. Okay, so before we can do that, we can redraw the circuit first. Okay, so the circuit can be redrawn like this, where here is your voltage node V2, here is the voltage node V3. So that's why here you have plus minus V2 plus minus V3. Okay, and then after that you can apply KVL around the loop. So here you have negative V2 plus 5 plus V3. Okay, equal to 0. Alright, so this co-equation we consider as a support equation. Okay, so for case 2, Usually, the voltage source in the supernode provides the constraint equation necessary to solve the node voltage. Okay, so the constraint equation represented by the node equation and supernode equation, and then the support equation. And then the supernode has no voltage of its own. Okay, so you still need to apply the individual voltage node, which is V1, V2, V3, and so on. And then the supernode require the application of both KCL and KVL. Okay, remember you need to apply both KCL and KVL to the supernode. Okay, so let's have a look at the following example 3.9. So based on the circuit, you need to write the support and supernode equation for the following circuit. Okay, here is your supernode. Okay, now you have a current that going in I1, I4, and current that going out from the supernode is I2 and I3. And then here you have a supply of VB connected between the node A and node B. Okay, non-reference node of A and non-reference node of node B. Okay, so here you need to write the supernode equation. So you need to apply the KCL in order to write the supernode equation. And then for support equation, you need to apply the KVL. Okay, so the solution for this example, so you can just redraw back your circuit. So based on the circuit, how you apply the KCL. So the KCL I1 plus I4 will be equal to I2 plus I3. So this is considered as a supernode equation. So for the KVL, you need to apply the KVL at the supernode loop. Here we call as a supernode loop. Okay, so you have because here you have a node A, right? So okay, here is a current will be flow from positive terminal to the negative terminal. So that's why you have positive, negative, VA. Same goes to here. Current will be flow from the positive terminal to the negative terminal. So that's why you have VB. Right. So you apply the KVL at the supernode loop. So you have negative VA plus VB. Okay. V, the capital letter B. And then plus VB equal to 0. So this is considered as a support equation. Okay. Next, we go to the second example, which is example 3.10. Okay, find V1 for the following circuit. Okay, so in here you see you have a supply of current, you have a voltage source 7 volt that connected between the two non-reference node. Okay, so here you can consider as a supernode. Alright, so okay, first you need to assign the node voltage and branch currents to the n-1 node. So in this case we have 1 node, 2 node, and 3 node. So 3 minus 1 is 2. So here you have VA and VB. Alright. And then after that you assign the branch current to each of the nodes. So here I have I1. Here is I2. Here is I3 and here is I4. Okay, I didn't assign current to here and here because this one we can consider as a supernode. And then next, we apply the KCL to the supernode. Okay, so here you have a supernode and then you have a current that going into the supernode is I1. And then you have the current that going out from the supernode is I2, I3, and I4. So in this case, I1 will be equal to I2 plus I3 plus I4. Okay, and then after that, we just apply the Ohm's law in order to represent the branch current in terms of the nodal voltage. So I1 here will be equal to 2 ampere because you have a current source equal to I2. I2 is VA minus 0 divided by 4. So VA over 4 plus I3 is VB minus 0 divided by 2. So VB over 2. And then for I4, VB minus 0 divided by 2. Okay, VB over 2. And then after that, we can further simplify the equation. So finally, we have 8 is equal to VA plus 4VB. So this is considered as a supernode equation. Okay, and then after that, we just apply the KVL around the supernode loop. So in this case, we have a positive, negative VA. Okay, so the current will be flow from the positive positive terminal to the negative terminal. So here is a VA. Okay, so the current I4 will be flow from the positive terminal to the negative terminal. So here is the VB. Okay, so you apply the KVL around the supernode loop. So here is negative VA plus 7 plus VB is equal to 0. Alright, so this is considered as your support equation. Okay, and then next you can rewrite your both of your supernode equation and then the support equation in terms of the matrix form. So now you have 1, 4, 1 and negative 1 multiplied with VA and VB equal to 8 and 7. So finally, you can solve the equation 1 and equation 2, or you can solve the supernode equation and then the support equation by using your calculator. Or you can also, based on the matrix, this matrix, you can use the matrix function in your calculator. So finally, you can get VA is equal to 7.2 volt and VB is equal to 0.2 volt. Okay, so but in the question, it's asking about the V1, right? So V1 is equal to VB. Okay, so that's all for now. Thank you for your time and thank you for watching my video. I'll see you in my next video. Okay, bye.